Dar la bienvenida a este webinar, Reuso de aguas grises, desafíos y oportunidades, donde tendremos el día de hoy como expositor al profesor Amit Gross, experto en reutilización de aguas grises y director del Instituto Zuckerberg de Israel. Es para nosotros un placer y un honor contar con el profesor Gross el día de hoy en esta segundo webinar, digamos, en el ciclo de webinar del proyecto Greywater Reuse. Es para poder conocer de primera fuente la experiencia, digamos, y el conocimiento de países que tengan un avance exitoso y estén innovando en materia de reuso de aguas grises, como es el caso particular y bien conocido de Israel, que es referente mundial en esta materia. Compartiremos la conducción de este webinar con el profesor Dr. Ricardo Abejón, subdirector del proyecto Greywater Reuse. Ambos estaremos atentos a las preguntas que nos hagan a través de la opción de preguntas y respuestas que tiene abajo en la barra esta ventana Zoom. Ahí, obviamente, estas preguntas se harán a través de la mediación del profesor Abejón posterior a la presentación del profesor Amit Gross. Saludar hoy día, agradecer. Welcome, Professor Gross. Thank you very much to accept this invitation to participate in this webinar program of our project. Y quisiéramos presentarlo. El profesor Amit Gross es profesor y director de The Zuckerberg Institute for Water Research en la Universidad de Ben Gurion de Negev, Israel. El profesor Gross completó sus estudios universitarios en la Universidad Hebrea de Jerusalén, Israel, y obtuvo su Master of Science y su PhD en la Universidad de Auburn, en Estados Unidos. Durante su formación postdoctoral en Australia y en la Universidad de Ben Gurion del Negev, Israel, estudió diversas temáticas ambientales relacionadas con el tratamiento y reutilización de agua. Y sus actividades académicas actuales se centran en la reutilización de aguas grises residuales para el riego, tratamiento de residuos orgánicos húmedos para su reutilización eficiente y la minimización de contaminación ambiental, el tratamiento de efluentes en acuicultura, en sistemas de recirculación en acuicultura y sistemas acuapónicos. El profesor Gross ha sido autor, coautor de más de 100 artículos revisados por pares y una monografía. En 2020 recibió el premio Stretch BGU de la excelencia en ciencias ambientales. En este contexto, entonces, los invito a escuchar la presentación del doctor Amit Gross, Reuso seguro de aguas grises, desafíos y oportunidades. Professor Gross, thank you very much to participate in this webinar and the time you are for presentation.
Shall I start? Yeah.
Yes, please.
Yeah, okay. So thank you for the introduction and thank you for inviting me and for everyone who attends the presentation. I would like to start and take a couple of minutes and say where we are from, and maybe it will give a sense of why water in general and greywater in particular are so essential in this part of the world. So to your right, you see a map of Israel, and I'll say a word towards the end about what's happening here. Otherwise, I feel it's like being an elephant in a China room, in a China store. But anyway, we are. You can see that towards the south of the part of the map, it says the Negev, and then there is a black dot. We're pretty much located at that region, which is the very center of the Negev desert. And we have very little rain around us, and you can see the views that I can see from my window. So it's really a desert area. A little bit, well, it's more rainy than the Atacama Desert in Chile, but it's quite dry. So water is really a necessity in this part of the world, and specifically in this desert. The university, the Ben Gurion University, has a campus in this area. So our main campus is in Beersheba. It's a major city, but we're a smaller campus, only graduate studies. And it's called the Blaustein Institutes for Desert Research. where we are 3 academic institutes. You can see one is to do with agriculture and biotechnology. The other one that I'm directing currently is the Institute for Water, the Zuckerberg Institute for Water Research, and then the Environmental and Energy Research, which is doing solar. And basically, many or most of our studies are related to food, water, and energy because they're all interconnected. And obviously, greywater is part of it. We're about 300 students currently, about 70 researchers, and only graduate students. And if I may, I would say that we're looking for good students. So if anyone in the audience is up to a very interesting adventure, I invite you to contact me or us at the school. And again, as a very brief background, I would say that 45, according to the UN, 45% of the world population will be living in countries or is already considered arid zone, and half of the world will live in desert, basically, or in arid regions very, very soon. And actually, this number was updated recently. Right now it stands on 47%. So the issues of water and water recycling is so important and tremendous. And I don't need to convince probably most of the people here, but I wanted to say that as a baseline. The other thing, very general, before I deep into the topic, is I want to remind us all that water is not only that it's crucial resource, but it's finite in this world. So there is a known amount of water, most of it, 97 or even more percent of it is really not so available to us because it's either frozen on the in the poles or in the ocean or in places we cannot get it. It's not readily available. So the very little water that we do have, surface water, is actually not enough to supply the amount of water that is needed, because as population grow, we need more and more water. Not only that, we contaminate our water, so basically our available resources are declining and our need is increasing, and we need new water resources. I would just mention that there is lots of room for improvement in our current use, and much of it goes with agriculture. And you can see that as of now, we're pretty much irrigate about 3 times more than the plant needs. So we're very inefficient. And agriculture, as you can see in the right-hand figure, will grow with the consumption or the demand by agriculture will be nearly 90% very soon. So much of the effort should probably go into this direction worldwide. So that's about the quantity. But the other issue is obviously the issue of quality. And as you can see in these figures, much of the water is contaminated, and that affects so many people in this world. And I don't know, at least in here in Israel, we're really privileged because we never think about it. There's always water in the tap. They're always good for drinking. There is no, I mean, there is shortage, but there is no real shortage to the population, where 50% of the people, in developing countries suffer from one or more water-related diseases. Every few seconds, a child dies from water-related issues. Lack of adequate sanitation, fresh water and fish, the natural habitats are declining, etc. So I know that there is a good chance that many of you are familiar with that, but it's really important to stress this when we go to talk about this topic. And now I took a slide from Glenn Dieger that just talked about the part of the water issues one time, and basically part of the part of the reasons or the reason for partially for that is probably that we actually planned all our systems about 100 or 150 years ago, where global population was less than 2 billion. We mostly lived in rural areas and we were lacking modern technology. But as of today, we're not 10 billion yet, but we're about 8 billion people, mostly in urban areas, and we're experiencing a greater resource constraints. And the question to come in mind is the plans that we had in the past, which we call it the linear system, because we took the water away from the city, we introduced it into the city, and we took it out from the city with or without treatment, depends where. Is this a good solution? And I think I don't need to convince any of you that the answer is, of course, no. And any solution or recent solution will have to introduce some sort of an integration between the most abundant centralized units to decentralized units of wastewater and greywater units. I think I lost you. Is that?
Yes, we
Are
are
we
connected.
back? We got lost, I feel. I saw my, am I? Okay, great. So, we're going to go over and see this decentralization or part of this integrated system is in this presentation. And obviously on the domestic use, we can separate on-site the gray water, which is the shower, basins, laundry, kitchen, dishwashers, yes or no, it depends who you ask and the context. And the black water, which is the toilet water, and that's and that would be the topic of, and we'll go over that. So why gray water, you surely know, but again, in order for this to be the baseline, I would say that obviously it can save quite a lot of water, maybe up to 50 or 60, sometimes even 70% of the water volume, and less than that, but of the water cost on a household level. And again here, and I want to mention that I will not get into that much, but it's very different if we're talking on a household or a very small area, or a multi-story building. You know, it's very, very different, or a neighborhood. So the sizes are very important, but we'll not touch that too much. We will relate to gray water reuse in the on-site or the smaller scale on the smaller scale size of things. And you can see that even when we say gray water and talking about places, there are different places, and in each place we have, you know, people are producing more or less typically according to the economy of the country. So you see that in Jordan, which is a country nearby us, here in Israel, just with the border with Israel in the Mediterranean, the average consumption per person is 50 liter of gray water per day, where in the US it's 5 times more almost in the, with 225 liters per day, and in Israel is about 150. And you can even see that the percentage of the toilet is different, because some would have flushing toilet with no water savings like in the US, and some would have dry toilets or very little flushing toilets. So, it's very, very different. And we have to keep that in mind, that although I'm going to generalize lots of things, it's not always can be generalized. And that's true. For example, when you say saline water, what is saline water? How salty it is saline, and what's the ion composition? So we're at the same place here when we're talking gray water, but let's try and get the common grounds on it, but just to keep it in the back of your mind. So why gray water? It's much less polluted than the full domestic, because it doesn't contain the fecal matter. It can supply water even in droughts, or when we do not have water available, because we always consume water. We cannot do that. But for example, if we want to use it for garden irrigation, then we may not have enough water in our house or in the country because of drought. But still, since we're going to use it in the home, we can use it then in our garden, the treated wastewater or gray water. And obviously, it contains some nutrients, and that is another advantage. So these are probably the major advantages. It can save some money if we do it correctly. And here I just put it basically so you have it. I'm not going to go over this slide, but you can see easily that under the gray water column, you can see that it has some nitrogen and phosphorus and potassium. So if it is used for irrigation, it has a benefit. If it is used for other treatments, not necessarily. But there are quite a few challenges into the gray water reuse, and I would divide it into three major ones. So I'll start with the from the right to left, and I'll say one is physical, and I don't know if many of you ever thought about it, but let's assume that you live in a house when the pipes, and all the sewage is designed for a certain amount of water that and the flow is designed to contain the toilet, and now we remove 30% of the 60 or 70 or 50% of the water, because we take the gray water away from these sewage pipes. Then what will happen to the excretion? Will they flow to the sewage? So this is one issue, and again, I'm not going to talk about it a lot today, but I would like you to remember that. And if we go into gray water reuse on a wider scale, then it definitely has to be taken into consideration in all of our designs. The other thing is health risks, and I'll go over all these topics. And that's spread of pathogens and pathogenic organisms, and sometimes antibiotic resistance bacteria, and issues with endocrine agents and things like that, or contaminants like EDCs, remains of medicines, etc. And what happened to it? This is a big issue that needs to be addressed. Although I'd say it's less than the full domestic wastewater, it's still out there, and apparently at large quantities. The other thing is the environmental effect, because if we reuse it, and if we reuse it directly, what happens to all these compounds, the nutrients, the suspended material, the surfactants that actually now is higher than in the full domestic wastewater because the toilet stream usually do not have soaps. So actually surfactant concentration increase, and we'll see what it does to all that. So these challenges are out there, and they must be treated very well, I think, before greywater can be reused safely. And that's not the case in many places in the world, but we'll discuss that as we go. I already mentioned that, and I said that we'll not mention it too much, but again, I want to emphasize the difference between on-site or small scale and centralized or larger scale units, because in larger scale or in centralized wastewater, even if it is greywater, in centralized systems, water quality and quantity is pretty uniform. And it doesn't matter if someone leave the house or there are visitors that are coming, because overall there is a large number of people that supply wastewater. So the quality and quantity can be pretty much predicted quite well. Where we are working in smaller places, if a family, let's take it as a farm, okay? And if the owner of the farm leave their house for a holiday, then there is no greywater at all. And if visitors are coming to this place, then there can be 5 times more greywater in terms of quantity. And also the quality changes. And that changes on a daily basis and over time. And this is extremely important, and I'll show you later on why. But where normal wastewater treatment do not need to take care so much on the changing quality and quantity, greywater treatment system must. And I'll show you later that it's a big issue, because at least initially, much of the solutions to greywater treatment was to downscale typical wastewater treatment that were designed for much larger volumes, and the water were considered uniform, which is not the case with greywater, specifically not from on-site systems. And I'll just show here that we can see just the daily change over the day, and it just makes sense because around 6 in the morning to 9 in the morning, we all at home washing our face, maybe taking showers, etc. before going to work. Then the water, greywater that we produce is smaller because we're at work, and we start coming back from work around 4 o'clock, and then towards evening again there are activity in the house, and then we go to sleep and there is little activity, so there is no greywater. So just over a day, the quantities that is changing, and this is very important for treatment, because many of our wastewater or greywater treatment systems are biological, and the bacteria, I know that they didn't read the book, but they don't like these changes. They want something uniform, and these kind of things is quite problematic. The other thing, so this will be the quantity and how it affects. When we're looking about the quality of the greywater, we can see, and this is like a box plot, and you can see that the dot in the middle, the purple dot in the middle, is the average, and the line in the middle of the box is the median, and then it's the 25 percentile and the 75 percentile. But what's very, very distinct here, that these boxes are very, very wide. And it's not accidentally that they are wide, because greywater quality is changing dramatically over time and in general. And that's again making things very difficult if we want to treat it. So look at the total suspended solids on the right upper graph. It's going from nearly zero, if we washed our hands in the sink, all the way to 150 if, I don't know, we cleaned trousers or clothes in the dishwash, in the washing machine. So this is something to look at, and this dotted red line is the guidelines in Israel, what's allowed for release or for reuse. And you can see that mostly none of the parameters that the greywater, raw greywater, are not meeting the guidelines. So basically, in order to reuse greywater, we have to treat it. The same thing is with pathogens, and as indicated here by fecal coliform. And what you can see that even after biological treatment, but not disinfection, the range of bacteria is anywhere between 10 to the second fecal coliform per 100 ml to 10 to the fifth fecal coliform per 100 ml. Again, the difference and the change is dramatic. Other things that we see is the effect of greywater on the environment. And to your left, you see two sand boxes, one that was irrigated with just tap water on the left, and you can see how nicely the water flow through the sand was symmetric and neat. But if we introduce surfactants into the sand, so we coated the sand with surfactants because greywater contains surfactants, and we saw that, I'm not going to show it right now, but we saw that after irrigating sand with greywater, the surfactant concentration in the soil accumulates. So we took the surfactant concentration that we found naturally in one of our studies, and we irrigated with just normal greywater. And what you can see is, look at the circle, you can see the hydrophobicity that was created on the soil. So after a while, the sand became hydrophobic, and that's just because of untreated greywater reuse. And you can see the lettuce that doesn't look very well. We chose lettuce because it's a fairly sensitive plant, but when you use raw greywater, you may have, or you might have, issues with the environment and the plants if it goes for irrigation. I would just say here that I remind you that the major usages for treated greywater would be either irrigation or flushing toilets. Flushing toilets would be mainly in the city in a multi-story building where on-site it typically goes into irrigation. So the conclusion from all that is that greywater must be treated, at least in my eyes, and I know it's not done everywhere. Sometimes we just use diversions, but I think that I'm pretty certain about it, that if we want to reuse greywater safely, we have to treat it, and we have to take into consideration this water quality and quantity differences. So I'll just give this statement, and I mentioned that we tested a bunch of greywater systems, wetlands, activated sludge, different sand filtration, etc. But as I just mentioned a minute ago, this misconception regarding the greywater quality either led in the past to undertreatment, and if we had treatment, it often was inappropriate downscaling of large domestic wastewater plants without taking into consideration the variation of water quantity and quality over time. So again, I'm gonna show just one system that we studied, actually we developed, but there are quite a few others nowadays that took these things into consideration. And what we did here, we called it a recirculating or recycled vertical flow constructed wetland. And basically, you see it's built out of two containers. The upper one, well, maybe I'll show that. The upper one has a bed on the upper tank. The tank is perforated with holes, and water trickles like in a trickling filter into the reservoir. Okay, the reservoir is full up with filled with the water, and there is a pump that recirculates the water from the bottom tank to the upper part. To the upper part, and then vice versa, until a certain time that the water quality is good enough and it can leave the system, and then another batch can fit in. By doing that, we can intensify the unit and do the treatment very efficiently, and with in a very small size. Now, why is it so important? I see that the movie doesn't work here. It's like animation, but it doesn't really matter. Why it is so important? Because what happened here is that you can see here the water flow and how the bottom part is filled up. And what happened here is that there is aeration, which is quite good, and it prevents smells. The plants on the top prevent people from sticking their hands, and it's aesthetic, like hopefully like you saw in the first slide that I showed it in a garden. And what happened is that whenever we empty this thing, we leave a certain volume in the bottom. And this volume is actually diluting the next batch. So basically, it reduces the fluctuation on the system. As we said, the bacteria doesn't like too much fluctuation. It can also, if we don't have water for several days, the system do not dry. It keeps going and going because we leave some water at the bottom. So we leave the system alive, again, without many changes. And that actually solved quite a lot of issues, as I'll show you shortly. Then the water leaves as we said, the water leaves the system for irrigation or flushing, toilet, or whatever. And then we fill up a second batch, as we just said, and that worked nicely. We can then disinfect the water, the treated water, as it goes out. And what we see here is the same figure that we saw earlier, but now I added the treated gray water bit in the upper part. And what you can see is that if you look at the BOD, the biochemical oxygen demand, it be very little, nearly zero after treatment. The total suspended solid would be reduced to less than 10 milligram per liter, etc. The COD. And basically, we treat the water at very high level for unlimited irrigation, and that's with all parameters other than the bacteria. And then we need the disinfection bit, and after chlorine or UV disinfection, bacteria level goes down. And you saw it's basically two pumps and two containers. That's all there is to it. We put several of those systems in Piura, actually not too far away from you in Chile, as part of a collaboration with a university in Piura. The same thing we see when we look at treated gray water, fresh water, and naive treated gray water or freshwater irrigated soil. We see that when we use the treated gray water irrigated soil, the quality we do not have environmental impact on the soil because the water quality is quite high. And when we look at the system, or the robustness or the reliability of the system, then we see that that the mean time between failures is wherever we do it is pretty much 3, 4 or more months. So we know that if we maintain these these systems every 4 months, we do not expect any failures. Actually, we run these systems now for 15 years successfully, and we know that it's really, really robust. So we can do treatment very simple and very low cost, but it has to be maintained and it has to be done efficiently in order to work. The other topic that there are 2 more topics that I want to go briefly and very briefly in order to leave time for questions. Is the risk, the health risk associated, because that was a major concerns of many of the health authorities. And the Australian also tried to do kind of studies of that. And this is maybe one of the first good greywater microbial quality assessment in Australia. And I'll just say that they found that the risk, they compared greywater users versus the regular community, and they found after treatment, and they found no differences in sicknesses. We did an epidemiological study here, and we found no differences. Actually, if you look carefully, the amount of people that remained healthy that used greywater was a little bit higher, but this is probably because of the small size of our sample size. We do not have too many people here in Israel that reuse greywater. So basically, it's the same as the control. And interestingly, we can do that also theoretically through quantitative microbial risk assessment, which is basically has a certain scheme where you identify the hazard, you look at the exposure, you connect the dose response and basically the exposure and the hazard into a dose response model, and then you can characterize the risk. And I'm not going to go over that. I'm just going to say that you can do this whole thing theoretically. You can evaluate the health risk theoretically. And we did that for different, many scenarios. And what I'm going to show you here, I know it's quite busy, but let's look at the E. coli figure on the left top. And what you see is the guidelines limit, which is the DALI limit, okay, the red line limit. And you see the figures that are coming from the risk assessment model. And the x-axis is the concentration of this bacteria of interest, okay? And the probability on the y-axis, we have the probability of infection. And what we see, for example, if we go to the people who eat raw vegetables that were irrigated with greywater, the risk would be, or we would exceed the limit, the red line. You see anywhere the figure, the graph would cross the red line at around 10 to the second bacteria per 100 ml. So that means that if we count less than 10 to the second bacteria per 100 ml, the practice is safe according to the model. If we irrigate the garden, then the amount of concentration that is allowed would be more than 10 to the 3. But if we look at much more severe bacteria, for example, Shigella, the bottom right, you can see that the lines are crossing the DALI limit at a concentration which is less than 1 bacteria. Now, all these bacteria we sometimes find in greywater. So basically, what we say here, that although not necessarily it is risky according to the fecal coliform indication that we usually use, it may be an issue or problematic with other bacteria, and therefore we recommend disinfection for greywater reuse unless it's away from people. And when we compare this epidemiological approach and the quantitative microbial risk assessment model, what we see is basically that the QMRA, the risk assessment model, is much more conservative than the epidemiological study. So if we use that, we're really on the safe side, but not necessarily we have to use it. We can be more relaxed than the QMRA. So this is like a political issue. Last, in a couple of minutes, I want to say, and maybe I'll give you the statement and I'll just very, very briefly go over the real data, but I will say that greywater is not only or may not only save water on a household level or on the level of the user, but it can often be on a national level important. And this is just an assessment from Israel. And what you can see here that, and I'm with the outcome of the assessment. And then if we have another minute, I'll discuss the beef to that, or the causes for that. But in Israel, we could have saved, if we started to save greywater today, not today, like about 10 years ago, today we could have saved nearly 40 million cubic meter per year. And in about 10 years from now, or 20 or 15 years from now, almost 400 million cubic meter per day. We could have reduced our national electricity consumption by, you see the numbers, lots of gigawatt per hour, and maybe avert the construction of almost 2 desalination plants by 2050, which is a dramatic, reduce CO2 emissions and save billions of Israeli shekels, but it's still, if it's like divide by 4 and it would be in dollars. So maybe $4 billion by 2050. And the reason is that if we start using only on new premises greywater by 2050, and I'll be here, you can see that the difference or the saving would be around 140 million cubic meter, just because we irrigate or flushing toilets without taking new waters. In Israel, it's all desalinated water. So basically it would save 2 desalination plants or 1 big desalination plant with all its impact. And I would I want to finish by saying here, I want to be in this graph. It's a unique graph. I want to be here and say that when we look at the cost, or you see the specific energy on the y-axis and the source, the distance from the consumer and to the factory, we see that greywater reuse is obviously very close because it's done on site, and the energy that we use is very, very small if we compare it to desalination or just natural water use, etc. Because often the distances to all the other practices is much, much higher, and typically also the specific energy that is used. You will have these figures with you, so I guess that you can look at it more closely. And I'll just summarize and say that it is possible to reliably treat greywater by simple, low-cost, low-tech means to very high quality, which makes it an economical solution. If greywater treatment is maintained, the reuse or treated and disinfected greywater is safe for unlimited use other than drinking, and that greywater reuse is expected to be part of any new wastewater management paradigm and it is no doubt a green solution. And there are lots and lots of people that I should thank along the way, but some of my colleagues are mentioned here, Eran Friedler and Zeev Ronen and others, and many of my students. I had dozens of students working on greywater, and a nice fellow who donate quite a lot of money and funding towards this research. As I said, I would like to spend 30 seconds and say that this presentation, I agreed to do it and before, but I couldn't ignore it. It's in memory of so many lives that are gone. This war in Israel is very near you saw the map earlier, is very close to where we are. About 1,000 people died in the from the area, of which 100 or so from the university, our colleagues and students, and it's very sad. Much of the treatment was here in the Negev, not too far away from where we live, and nearly 200,000 people displaced from their homes at this time because of this war. And I wish that all this would have never happened, and it will be over very, very soon. So thank you very, very much for your attention, and I surely hope that you enjoyed and this presentation, and I'm happy to take questions. And I'll just get off this sharing, then maybe I'll be able to see the audience. Yep.
Thank you very much, Professor Gross, for your presentation and this excellent summary about water characterization, greywater characterization, treatment, reuse, and general aspects related to the water management. It's time for questions. Dejo con ustedes al profesor Ricardo Abejón, quien va a permitir la gestión de las preguntas, digamos, que hayan recibido. Y les pedimos, por favor, que todas aquellas preguntas que deseen formular lo hagan a través de la sección, digamos, el botón de preguntas y respuestas que está abierto durante este webinar.
Gracias, profesor Julio Romero, por dar paso y quiero agradecer antes de nada la presentación del profesor Almir Ross. Thank you very much, Professor Ross, for your nice presentation.
Sure.
It has been a pleasure to be assisting to this presentation. It is really interesting that it has promoted the search of several questions that I will ask you. For example, I would like your opinion about the management of estrogenic compounds in these fresh water. Have these pollutants been considered? Are the constructed wells effective in their treatment?
So yes, we actually study these things, both antibiotic resistance, but then estrogenic and EDCs in general, PCCPs in general, and typically the biological treatment is not very efficient in treating these compounds. So there are two approaches that I suggest, and which is we're using, and I haven't, I didn't have the time to go into that, but one is to use like an upper layer of absorbent material, activated carbon or something like that, granular activated carbon, because we need porosity, that these compounds are being absorbed too, and you can replace it once it's saturated. So every year or 3 years, it depends how much the layer is, then you can use it. The other way, which people have done before, and also doing a little bit with greywater, is to use as a disinfection ozone rather than UV or small scale UV or chlorination, The issue here is the size, the dimension of your system. You know, what's the volume that you treat? If it's in a household, to use ozone is irrelevant almost, you know. So it's an economical issue. But these are the two solutions that I would have for astrogenic, you know, for all these micropollutants compounds.
Following this issue about the emerging emergence, how is the greywater treatment affected by the presence of these emerging pollutants, for instance, triclosan of other pollutants delivered from the treating chemicals of the personal care products? What are the most worrying emerging pollutants from your point of view?
So that's a tough question. The truth is, well, I can say a few words, but I don't have a good answer to that. These micropollutants is still a very big debate, because we can find them in the greywater, but the quantities that we are polluting, because it's so decentralized, is so small that I'm not sure how big of an effect it does on the environment. It's health-wise to people, it's not a problem, because, you know, we eat these we eat these pills and these antibiotics, and we use these products on our face, you know, when we put the creams or we eat the pills. So we are consuming as people way more than anything we will find ever in the greywater. The issue is the environment. Okay, so the environment, it depends, you know, eventually it depends how much of these products are going into the environment and whether it's contained because it's just a garden or not, and what happens to it over time. So I do think we have to treat it, but it's not, probably it's not as dramatic as one may think. That would be, so if it's a small premises, I would use just absorbents and then toss it into the, you know, into once, as I said, once every time into the an appropriate dump. But other than that, I don't think there is one contaminant that is really more dramatic than the others in terms of greywater that I'm familiar with, at least. Yeah.
Okay. The next question is, what about the presence of microplastic and waste fibers, mainly from washing machines? How do they affect the treatment? Must be removed by a pre-treatment, or what is the best option to manage with this type of pollutants?
So this is, again, it's the same line of questions. Obviously, there's tons of microplastics in greywater. We measure it in wastewater and greywater. We have right now a student who is doing just that from domestic wastewater, and we find quite a lot. What we see is that most of the plastics is removed by the treatment. So over 90%, maybe 95% of the plastics is removed. Having said that, still this 5% is quite large number of plastics. It doesn't affect the treatment. That's not the issue. It will affect the environment. Again, how significant, I cannot give a good answer to that, but I do remember that typically greywater is very small volume and very distributed. So the effect is going to be less than, domestic wastewater, reuse, which in Israel, we reuse our domestic wastewater. 90% of our domestic wastewater is being reused. Okay, so greywater is ridiculously insignificant when you compare it to that. But still, it's something that as time goes, we'll have to take care of these things more and more. And we're working on solutions to try and find solutions to removal of microplastic or improve the removal of microplastic in the treatment. Again, if it's a household, it's irrelevant. No, nobody will invest the money. If it's a neighborhood, it's worth the trial. And basically, we're working with coagulation and things of that kind in order to do this, to improve their removal, sun filtration and coagulation. That's what we're doing currently. And ozonation, by the way, which is not very efficient, but we're trying still.
Okay.
Yeah.
Another question is, what kind of measures have Israel implemented to promote the greywater reuse, and what would you recommend to Chile in order to promote these
I
technologies?
didn't understand the question, so please repeat it.
What kind of measures have Israel promoted in order to favor the implementation of greywater reuse system, and what would you suggest to Chile in order to promote the same objective, the reuse of greywater?
Okay, so that's it's like stepping on my blisters, and I'll explain why. Israel has a very strong group of researchers, politicians, water specialists, etc., people from the Ministry of Health who actually developed a standard for greywater reuse, a very high quality standard. So, and it was approved by the Standard Authority of Israel. I can send you the draft, but the Minister of Health didn't sign it lastly. So greywater reuse in Israel is not allowed actually in private houses. So we're doing it mainly for research, and many people who are actually just, when the government say that something is not allowed, Israel is like that, and they do the opposite. And so I'm kidding, but in many ways we have thousands of people who are reusing greywater and do it incorrectly because the standard was not approved. But there is a very high quality standard, and if I have to recommend Chile, I would just do a standard that people can actually stand, not a standard that is somewhere up there that nobody can actually apply, but a standard that is feasible and that would work very well. We're ready for that. We just need the courageous Minister of Health Minister in order to approve it, and we're on our way. So I hope I answered the question and that I understood it.
It's okay. The next one is, what are, from your point of view, the most relevant factors to select a technology for greywater treatment?
Yeah, so basically it has to be low cost, it has to be low maintenance. These are the major issues that I would say, because typically it's being handled in rural areas or in places where there is little technical help or less. So it really has to be robust and efficient with little maintenance, and as I said, low cost. But the quality, the outcome has to be for unlimited use for irrigation. That's what or flushing toilets. And it's possible to do both, to have it low cost, low maintenance, and safe for reuse. One of the systems I just showed you, and I know it very intimately, but there are many, I don't know if many, but there are a few others out there that are really, really good systems and not very costly. There are others that would not do the work, by the way. There are tons of systems that are just done by unprofessionals, I must say.
Okay, we are going to finish with the last 2 or 3 questions. For instance, what is the substratus for the welders that you would suggest as the best option in this type of treatments?
What is the
substratus, the support of the welders? What do you suggest?
The support of the, I didn't understand.
Of the welders. The constructed wetlands?
The wetlands?
Yes. What
So-
is the status?
Okay, thank you. So I think that wetlands is a good solution, but I really think that unless you have lots of space, vertical wetlands are the right solutions, and if it can be recirculating vertical wetlands, it be the right direction. I think that, and I would move from wetlands for a second. I think that membrane technologies are developing, and there is a good chance that within a decade or so, it'd be very cheap, and maybe there should be movement into MBR. So it's like membrane bioreactors, and this would be a good solution too, and that would be solving some of the nature-based solution. But the status is wetlands is now very developed. It's a doable solution, and I would recommend, if you, at least specifically if you want to reuse the water and not just waste them to the river after treatment, then a vertical wetlands would do the trick much better than horizontal flow wetlands.
Okay. And just to finish the last question, the Israel government did some changes in the building laws in order to allow to segregate the greywater from the other streams. How
Yes, the Israeli government banned greywater reuse. So greywater is considered as wastewater. They don't separate the two officially, and the wastewater reuse guidelines are so strict that if you really want to follow them, you cannot do it on a household level. It would cost so much that it's irrelevant. So if you, I don't know, if you want to do it in a country club, you can do it. But if you want to do, a large country club, like a place with a swimming pool and so on. But if you want to do it on a household level, it's impossible. And that's what we did in the standards. We managed to do it in a way that it will be very safe and uncostly, but the minister didn't manage to sign this standard. So we're still waiting for this to happen. And I was very involved. That's why I'm very frustrated.
Thank you very much, Professor Ross, for your answer. Y ahora devuelvo el turno de palabra al profesor Julio Romero.
Thank you very much, Professor Gross, for your answers to these questions. Thank you very much to share your knowledge and experience about the characterization and treatment of greywater and reuse and the experience of Israel. And quisiéramos agradecer también a todos los asistentes a este seminario por acompañarnos, digamos, esta mañana. Hemos tenido una nutrida asistencia y los quisiéramos invitar a seguir en contacto con nosotros. Cualquier pregunta o respuesta también pueden visitar nuestro sitio web, proyectoaguasgrises.usach.cl, donde podrán también disponer de información de este seminario y también de las actividades del profesor Gross. Así que muy contentos de compartir esta segunda iniciativa, segunda instancia, e invitarlos, digamos, a que puedan también informarse de las actividades científicas, técnicas y de divulgación que vamos a seguir desarrollando en el marco de este proyecto, específicamente en el sitio web y nuestras redes sociales. Así que muchas gracias. Thank you, Professor Gross. It's a real pleasure, especially in this difficult time. And thank you very much for your webinar today.
Thank you very much once again, and for everyone who attended.
Bye-bye. Thank you very much.
Bye-bye. We'll be in touch.